In this video, what we're going to be doing is continuing on with the statistics aspects and looking at what does like a normal distribution look like and what the data would look like if it were plotted and things like that. We're also looking and touching on the idea of probability. Now, probability is basically looking at how likely something is going to occur or how likely something is true. And probability basically goes from 0 to 1. Okay, 0 saying, no, it ain't probable at all, to 1, it is going to happen, sort of thing. And what I want you to do is in Canvas, under the Chapter 8 Intro to Statistics, go to the Rossmann-Chance applet collection. And I want you to play. What we're going to be doing is looking at the idea of Reese's Pieces. Try that. Now, in this situation, what's happening is we're looking at, get this out of the way in case it's there. What we're going to be looking at is probability of orange pieces being pulled out. In this case, you have a population of a bunch of Reese's Pieces, and half of them are orange. And so if you have a probability of orange, 0.5, that means that anytime you draw 25 candies out of the machine, 12 and a half of them should be orange. And so what we're going to do here is look at that. All right, so what does that actually mean and how does it work? So we have this Reese's machine. We're going to animate this puppy and we're going to draw a sample of 25 candies and see how many are orange. And you see in this case, 15 of them came up orange. Well, what we do is we will put a plot in here on the summary stats of where the 15 was. So let's draw another sample, see how many we get as far as the orange is concerned. At that time, we got 12. Okay, real close to what we would expect to get whenever we take a sample of the candies. This time we got another 15. Draw another sample of 25. And in this case, we got 10. So you can see that there's going to be some differences. There's going to be variance as far as every time you try to draw something, there's going to be some differences as far as how many you get. Draw another sample. You see that this time we got another 10. I'm going to stop animating and I'm going to draw 10 samples at a time. You can see that this time we got how they came up. All right, we got one down here with just 7. We got another, maybe another one with 14 and things like that. Let's draw another 10 samples and another 10 samples and another 10 samples and another 10 samples. And you can see that what's happening is you're going to get that central tendency coming in where you would think it would be. The more data you pull, the more it's going to start centralizing around that central tendency area. Draw another sample and another and another. You can see we're starting to get something that looks like a normal curve by doing that. So you can play with that. You can do this, change the probabilities and see what happens. Change the number of samples, number of candies that you do. So try that in a couple of different ways. Now there's also another one to think about as far as sampling pennies. In sampling pennies, what's going to happen is what we want to do is we're going to look at this. You have a bunch of pennies. You have 1,000 pennies. Okay, in this case, 1,000. Population size is 1,000. You have years and you have the age, how old that is from this particular. This was done in 99. So you have the year, and as far as the pennies are concerned. And then you have all these different pennies that are out there. What you're going to do is you're going to pull some pennies and see what it's starting to look like. So we're going to start looking at the sampling options. All right. Each time we're going to pull one sample of 10 pennies to see how many, what the years are, what the spread of the years are on those 10 pennies. So we draw a sample, and you can see in the data plot that for those 10 pennies, these are the years that we got. So you can see there's each and every penny right there. And there's kind of the mean of that sample right there. You can see that right now, the mean is 1976, okay? And the standard deviation is 5. So let's draw another sample. See what we get. Ooh, we got some that were much more current. in this case. The mean was way up here. The mean was 1987. Draw another sample. This one, the mean was 82 in that sample. You can see where each of those pennies were, the years for those pennies, and some of the stuff here. We keep drawing samples of pennies, and you can see that things are starting to change. For the population, the mean is 1986, and you're starting to see there may be some tendencies here to show what some of those things are. If we overlay a normal distribution on that, we're starting to see where the normal distribution is. You can see that it's really pretty flat. Let's draw some more samples. You'll see that the distribution is starting to go much more towards what it might be over here as far as the mean, starting to centralizing around the mean here. As far as the distribution is concerned, let's blow some more samples. And you can see that as the more samples you get, the more closer you're going to get to that population as far as some of the things that you're doing. So right now, with the samples that we've pulled 109 samples out of that population. Each time we pull one, we got, so far, we're getting a mean or an average of 1987, which is close to the population mean of 86.7. And the more and more that we do, the closer that mean is going to get to what the population is. Right now, the standard deviation is 3 years. All right. So play with this. Here's another one that you can play with as far as looking at the idea of probability. And if you pull some of these samples, what does it actually mean? If you have questions, give me a shout.